students, from today we are going to start second chapter, Eigenvalues and Eigenvectors. Eigenvalues and Eigenvectors. Okay. We have observed that linear transformation x to Ax transforms a vector x into another vector A. The goal of this chapter is to study the action of this linear transformation. In particular, we study equations such as Ax is equals to x, Ax is equals to 2x, Ax is equals to 3x, etc. Okay. In general, we study the matrix equation Ax is equals to lambda x for some scalar lambda. Okay. Now we will see definition of eigenvalues and eigenvectors. Definition of eigenvalues and eigenvectors. An eigenvector of n by n square matrix. N by n square matrix A is a non-zero vector. Is a non-zero vector x such that Ax is equals to lambda x for some scalar lambda. A scalar lambda is called an eigenvalue of A if there is a non-trivial solution. If there is a non-trivial solution. If there is a non-trivial solution x of Ax is equals to lambda x. Ax is equals to lambda x such that a vector x is called an eigenvector corresponding to lambda. An eigenvector corresponding to lambda. An eigenvector corresponding to lambda. See here, students. An eigenvector of n by n square matrix A is a non-zero vector x such that Ax is equals to lambda x for some scalar lambda. Okay. A scalar lambda is called an eigenvector of A if this equation Ax is equals to lambda x has a non-trivial solution. Okay. The vector equation Ax is equals to lambda x is very important to determine if given vector x is an eigenvector of square matrix A or not. Okay. Now we will see example. Example 1. Let A is equals to matrix 1, 6, 5, 2. For given lambda is equals to 7. We show that lambda is an eigenvalue of A. So that lambda is an eigenvalue of the solution. Lambda will be eigenvalue eigenvalue of A if the equation Ax is equals to lambda x has a non-trivial solution. Consider Ax is equals to lambda x. For lambda is equals to 7, this equation becomes Ax is equals to 7x. That implies Ax minus 7x is equals to 0. That implies A minus 7 into identity matrix x is equals to 0. Okay? This is a homogeneous linear system. So we solve homogeneous linear system. As follows. We solve homogeneous linear system as follows. A minus 7I is equal to A is what? A is matrix 1 6 5 2 minus 7 into identity. Here A is of order 2 by 2. So I is here identity matrix is of order 2 by 2. So this is 1 0 0. This is nothing but matrix 1 6 5 2 minus 7 0 0 7. Okay, this is nothing but 1 minus 7 minus 6 6 minus 0 is 6, 5 minus 0 is 5, and 2 minus 7 is minus 5. Okay, the augmented matrix is this is A minus 7 and we will write augmented matrix for this system. So that matrix is minus 6 6 5 minus 5 0 0. Okay, that matrix is 5 minus 5 0. Okay, reducing the augmented matrix we get next line, write down reducing the augmented matrix we get matrix 1 minus 1 0 0 0 0. Obtain this row echelon form of this matrix. Okay, so see here students, column 1 has leading 1, column 2 does not have leading 1. So here x2 is a free variable. Means what? We will get here, I will write, this implies x1 minus x2 is equals to 0. But here x2 is free variable. So we get x1 is equals to x2. Okay, so we will get x1 is equals to x2. So here we will write x1 is equals to x2 is the only solution, see here student, x2 is free variable, means what? We put x2 is equals to t, therefore we get x1 is also t. Okay, so its general solution is what? Set t t. such that T is belongs to R. Okay. This shows that implies homogeneous system. Homogeneous system. Which homogeneous system? This A minus 7i. See here. So 7i into x is equals to 0 means this has a non-trivial solution. Has a non-trivial solution. Therefore, lambda is equals to 7 is an eigenvalue. Of A, and corresponding eigenvector is an corresponding eigenvector is 1 1. Okay. Why this is 1 1? See here, because solution is this x1 matrix x1 x2 can be written as T. Okay, take T common, so here remains matrix 1 1. So this vector is a eigenvector. Okay, and this vector forms a basis of the eigenspace corresponding to the eigenvalue lambda is equals to 10. Okay, students, we have to check lambda is an eigenvalue of A or not. For that, we have to find out this equation has a non-trivial solution or not. If this equation has a non-trivial solution, then lambda is the eigenvalue of A. If this equation has no non-trivial solution, at that time lambda is not an eigenvalue of A. Okay. Here, second example, let A is equals to this matrix. For given lambda is equals to 4, we have to test whether lambda is eigenvalue of A or not. If so, if lambda is equals to 4 is eigenvalue of A, then we have to find corresponding eigenvector. Now, we know that lambda will be eigenvalue of A if and only if the equation Ax is equals to lambda x has a non-trivial solution. So consider Ax is equal to lambda x. So here, for lambda is equal to 4, this becomes Ax is equal to 4x. That implies A minus 4r into x is equal to 0. Put the values of A and so here we will get. See students, this is a homogeneous linear system. So we solve the homogeneous linear system as follows. Okay. So put the values of A. Matrix A is, therefore A minus 4I is equals to what? Matrix A is 3, 0, minus 1, 2, 3, 1, minus 3, 4, 1, minus 4 into I means here A is of order 3 by 3, so I didn't here I is of order 3 by 3. 4 into I, so here is 3, 0, 4, 0, 0, 0, 4, 0, 0, 0, 4, which is equals to, I will write here, see here students, 3 minus 4 is minus 1, 0 minus 0 is 0, minus 1 0 is minus 1, 2 minus 0 is 2, 3 minus 4 is minus 1, 1 minus 0 is 1, minus 3 minus 0 is 0, 4 minus 0 is 4, and 1 minus 4 is minus 3. Sorry students, here is 5. So here 5 minus 4 becomes 1. Okay. This is A minus 4I. Okay. Now we will write down augmented matrix for the homogeneous linear system. Augmented matrix is. What is augmented matrix? Augmented matrix is minus 1, 0, minus 1, 0, 2, minus 1, 1, 0, minus 3, 4, 1, 0. Row reduction of the augmented matrix Q matrix 1 0 1 0 0 1 1 0 0 0. Here I will write directly row reduction of this augmented matrix. Obtain this row reduction. This is homework 0. See here students. Here R1 implies x1 plus x3 is equals to 0 and R2 implies x2 plus x3 is equals to 0. Here third column does not have leading one, that's why x3 is free variable. x3 is free variable means what? We can find x1 and x2 in terms of x3. Therefore we will get values of x1, x2, x3 is equals to, here x1 is equals to minus x2, x2 is equals to also minus x3 and x3 as it is because it is free variable. So we will get x3 into minus 1, minus 1, 1. Okay, this is the coefficient of x3. This shows that lambda is equals to 4 is an eigenvalue of matrix A. This shows that lambda is equals to 4 is an eigenvalue of matrix A, because this equation has a non-trivial solution when lambda is equals to 4 and the corresponding eigenvector is, and the corresponding eigenvector eigenvector is -1, 1, 1, and the corresponding eigenvector is B. Okay. In example 1 and 2 we have discussed the method of finding eigenvectors whenever an eigenvalue is given. Okay. Let us take theorem. The eigenvalue of a triangular matrix the eigenvalue of a triangular matrix are the entries on its main diagonal. Are the entries on its main diagonal. Are the entries on its main diagonal. That is, if A is equal to matrix A11, A12, A13, 0, A22, A23, 0, 0, A33, then the given eigenvalues are A11, A22, A33. See here, students, what the theorem says. The eigenvalues of a triangular matrix are the entries on its main diagonal. That is, if A is equal to A11, A12, A13, 0, A22, A23, 0, 0, A33, then the given eigenvalues are A11, A22, A33. Okay. Let us take one example. Given matrices A are. First is A is equal to matrix 3, 6, minus 8, 0, 0, 6, 0, 0, 6. B is equal to matrix 4, 0, 0, minus 2, 1, 0, 5, 3, 4. Solution. First, see here, students, this is a upper triangular matrix because elements above the diagonal are non-zero, and this is a lower triangular matrix. Elements below the diagonal are non-zero. Okay. So this theorem says that eigenvalues of a triangular matrix, it may be upper triangular or lower triangular, are entries on the main diagonal. Okay. So here main diagonals are 3, 0, 2. So matrix A has 3, 0, 2 are eigenvalues. So matrix A has 3, 0, 2 as eigenvalue. 0 is an eigenvalue. This 0 is an eigenvalue of A, means the equation Ax is equals to 0 into x has a non-trivial solution. Has a non-trivial solution. Has a non-trivial solution. That is possible only if matrix A is not invertible. Matrix A is not invertible. Matrix A is not invertible means what? Determinant of A is equals to 0. Thus 0 is an eigen. Therefore 0 is an eigen value of A if and only if A is not invertible. Students, always keep in mind that 0 is an eigen value of A if and only if A is not invertible, means if and only if determinant of A is equal to 0. Now see matrix 2. Suppose this is it. B is equals to, this is a lower triangular matrix. So matrix A has, matrix B has 4, 1, 4 are not are as eigenvalues. As eigenvalues. Here 4, the eigenvalue 4 is repeated. Okay. Let us see one more theorem. Theorem is the eigen, if V1, V2 is V1, V2 and so on up to VR are eigenvectors that correspond to distinct eigenvalue lambda 1, lambda 2 and so on up to lambda r of an n by n matrix A, then the set V1, V2 and so on up to VR is linearly independent. For linearly independent, I will write L. Okay. See here, student, what does theorem say? If V1, V2, VR are eigenvectors that corresponds to distinct eigenvalues lambda 1, lambda 2 and so on up to lambda r of an n by n matrix A, then the set V1, V2, VR is linearly independent. Okay. So let us see one example. Example is the eigenvalue of the triangular matrix A is equals to matrix 0, 0, 0, 0, 2, 5, 0, 0, minus 1 r 0, 2, comma minus 1. Obviously, because this is a upper triangular matrix. Okay, so its eigenvalues are 0, 2, minus 1. we have to find the eigenvector corresponding the eigenvalue 0 to -1. Solution: the eigenvalues are distinct. Okay? The eigenvalues are distinct. First we find eigenvector corresponding to lambda is equal to 0. Here we can find out eigenvector corresponding to lambda is equal to 0 because determinant of A is equal to 0. Okay. Therefore, consider Ax minus lambda I Ax is equal to lambda x. Here lambda is equal to 0, so we will get Ax is equal to 0. Our A matrix, this is a homogeneous linear system. We solve homogeneous linear system. Okay. Here matrix A is 0, 0, 0, 0, 2, 0, 2, 5, 0, 0, minus 1. Okay. Into x1, x2, x3 is equal to 0, 0, 0. Augmented matrix is what? Matrix 0, 0, 0, 0, 0, 2, 5, 0, 0, 0, minus 1, 0. This is a augmented matrix. Okay. Sorry students, here no need to write down augmented matrix. Here we will get directly 2x2 plus 5x3 is equal to 0 and minus x3 is equal to 0. Okay. So minus x3, here we get, so this is equation 1 and this is 2. This 2 implies x3 is equal to 0. Okay. So 1 implies, if we put x3 is equal to 0 here, we will get x2 is also 0. But here column 1 does not have a leading node, so x1 is a free variable. So we will get values of x1, x2, x3 as equal to x1 is arbitrary, so keep it as it is. Why this is? Because x1 is free variable. Okay. x1, x2 is 0, x3 is 0. This can be written as x1 1 0 0. Therefore 1 0 0 is a eigenvector corresponding eigenvalue lambda is equal to 0. This is a eigenvalue. Okay. Similarly, we can find eigenvectors corresponding to 2, minus 1 are matrix 0, 1, 0, and matrix 0, 0, 1. Okay, so therefore here we have find eigenvectors corresponding to eigenvalues 0 to minus 1. Okay. Now we will use the theorem. See here, eigenvectors, eigenvalues are different, its corresponding eigenvalues are also different. So this states, so by this theorem, the set of eigenvectors 0, 1, 0, 0, comma 0, 1, 0 and vector 0, 0, 1 is linearly independent. Okay, so we will stop here. In next video we will discuss the characteristic equation. Thank you.